Hello everybody and welcome back to another CIV 398 assignment guide. So in this assignment guide, I guess, I was going to say assignment tutorial, but I guess it's all the same, so it doesn't really matter. We're going to be wrapping up assignment 2 by solving question number 5. So there's a question number 6, but it's bonus marks. It's pretty easy this week. I do recommend you guys go try your hand at it. I don't think you guys will have too much trouble at all. But if you guys just want to say, you know what, life's life's a bit stressful right now, I'm going to skip it this week, that's completely fine too. So with that being said, let's kind of jump into question number 5 and see what it has to offer. So it says a triangle has corners A, B, and C in the orthonormal basis set B, which is composed of E1, E2, and E3. And it wants us to determine the coordinates of the triangle after the following scenarios. So it gives us two scenarios, and then part C just says comment on the difference between the two scenarios. So part A says the basis vectors are rotated 45 degrees counterclockwise about the E3 axis to form the new basis set B prime. So if you guys are looking at the picture in your guys' assignment, I didn't include it here, but you guys are given a picture of what these scenarios, what they mean to help illustrate it. You guys will understand that this is just a change of basis, and this goes back to assignment 1 and quiz 7, so by this point, you guys are experts at change of basis. You're looking at part A thinking, oh, piece of cake, Clayton, give me something more challenging. And to that I say, okay, well, here's part B. And part B says, well, instead of changing the basis vectors, what happens if we take the triangle and rotate that 45 degrees counterclockwise about the E3 axis? So we got two scenarios. Both scenarios involve a counterclockwise rotation. The only difference is scenario A, we're rotating the basis vectors, and scenario B, we're rotating the triangle. So it may sound like this is going to be a little bit tough. Well, rotating triangle, well, we haven't really done that. What do we do, Clayton? Well, I'm here to show you because there's a little trick, and after the trick, oh, this is a piece of cake. After this, you guys will be so confident you'll be ready for the midterm. Well, maybe not quite that, but we're getting there. All right, so let's talk about the tricks. So to show you guys the trick, it's more something I have to illustrate to you guys. Because if I illustrate it, you go, oh, okay. If I try and explain it with words, I guarantee I'll create more questions than answers, and that's not exactly what I'm going for. So let's consider a counterclockwise rotation of the basis vectors. So this is the same as a change of basis. As you guys know, let's say we got E1 and E2, and in those basis vectors we have our triangle. And we say, okay, I'm going to apply my coordinate transformation matrix Q. And by now, you guys are very familiar with the two different Qs for rotation, one if it's clockwise, one if it's counterclockwise. Again, this is quiz number 7, nothing new to you guys. And as a result, we'll have our basis vectors rotated as such to create E1 prime and E2 prime. And from there, we can say, okay, well, this is basically our new scenario. We have our triangle, and we have our two basis vectors, and they make an angle theta with the triangle. And you guys know that it's very easy to calculate the new corners of the triangle because once we have Q, we just times Q by the original coordinates to get our new coordinates. So it's the exact same as change of basis, nothing you guys have not seen before. So now let's consider something a little bit different. Let's consider a clockwise rotation of the triangle. So remember, above we're doing a counterclockwise, but now let's consider a clockwise rotation of the triangle itself. So again, we start off with the exact same scenario. We have our basis vectors E1 and E2, and we have a triangle. But then we apply a matrix M, and we map the triangle so that the triangle is rotated clockwise. And this is our scenario. So we still have E1 and E2. That's not E1 prime or E2 prime because we didn't change the basis. But all we have is a rotated triangle by the angle theta. Well, as you guys will kind of see now, oh, okay, wait, that looks familiar. Oh, really? Yeah, it does look familiar. So if we take that whole picture down there, the two basis vectors and the triangle, and we slowly rotate that counterclockwise, we'll see we have this image right here. Oh, wait, that looks familiar. That's the exact same as the one above. So here's the trick to the question. A counterclockwise rotation of the basis is the exact same as a clockwise rotation of a shape. So that's the trick. So when we're looking at part A, we need to determine Q. Well, you guys, oh, Q, I know Q. I've dealt with Q so many times. But then when part B comes and you guys are wondering what M is, well, now that you guys know that M is just a specific case of Q, it's the opposite case of what we're wanting. So to summarize, the trick itself to this question is a counterclockwise rotation of the basis is the same as a clockwise rotation of the shape, and vice versa. So if we give you guys the two rotation matrices, and I say give you guys because I'm being quite generous tonight, but in essence, you guys should know how to derive these. It's not hard to derive. You guys should know where they come from, or at least write them down on your cheat sheet when you go into the midterm. But if you guys have these two matrices and you know what they are, well, you say, okay, well, part A is easy because I used the second matrix, counterclockwise rotation of the basis. And you say, okay, well, if part B is asking for a counterclockwise rotation of the shape, that means I use a clockwise rotation Q. So in that case, I would use the first matrix C. So after this, you guys will see that the question is very, very simple. As long as you know these two Q matrices and that trick, you guys are good to go. So the question was as simple as that. I hope I provided some clarity. And remember this trick. This trick is a demon on the midterms. It'll get so many students. They'll say, okay, well, I got a counterclockwise rotation of the shape, so it must be a counterclockwise rotation matrix. And they forget that it's actually the opposite. So it's a good trick. Remember it for the midterm. And yeah, that concludes question number 5. And in turn, this includes the marked portion of assignment number 2. So hopefully you guys didn't find it too bad. I think we were pretty nice this week. I think that's the goal of all assignments. We don't want to be too mean to you guys. We know that you guys have a lot going on besides continuum mechanics. So again, I hope that these videos helped you guys as well. I'm happy to do them as long as I know that they're helping you guys. So with that being said, thank you guys so much for listening. I will see you guys either in question number 6, the bonus question, or if you guys are, you know what, I deserve some time off, I'm going to take it easy this week. Well, if that's the case, I will see you guys in assignment number 3.